What is an IV curve and why is it important? Well, an IV curve is a graph that shows the relationship between current and voltage of a solar cell. It illustrates the amount of electricity that a solar panel can generate under various conditions. It's important because after testing a module or string, it can tell us how well the solar panel is performing and if you need to investigate an issue or consider a full module replacement. In the graph here, we see the max current it can produce when there is no voltage. That's what we see here on the left. That's the short circuit current, or ISC, and the max voltage it can produce when there is no current. And that's our open circuit voltage, or VOC. And if you notice here, we have current as the y-axis and voltage as the x-axis. So here we have zero current, and way over here we have zero voltage. This also indicates the maximum power output of a solar panel by multiplying the current and voltage values, which is equal to power, that's what we have here, at the maximum power point. So if we were to multiply each point along this line, so multiply this current value with this voltage, this is that line it produces. It produces this power line, or this power curve. And at the peak of this curve is our maximum power point. And this maximum power point is associated with this IMP, this current at maximum power point, times this voltage at maximum power point. By looking at the IV curve results after testing, we can figure out if the solar module is performing as it should, or if there's some actions we need to take to make it work more efficiently. So let's look at a datasheet. You can find the electrical performance of a new module from its datasheet. You can find the ISC, or short circuit current, the VOC, open circuit voltage, the VMP, and IMP all in the datasheet. The values in the table here are all under STC conditions, which are described at the bottom here. It's a 1000 watt per meter squared irradiance and a 25 degrees Celsius cell temperature. If you take a look at the graph shows the effects of the IV curve under different irradiances. So how much sun is hitting those cells. What we have here is the curve at 1000 watts per meter squared, which is what you would see at STC. We have 800 watts, 600, 400, and 200 watts per meter squared. So you get less and less sun or light hitting that module. You can see here that current is mostly affected by the irradiance changes, and voltage is slightly affected by irradiance. Let's take a look again at this 1000 watts per meter squared curve. So you can see here, if we take a look at the table, we can find the short circuit current at 13.85, which aligns right here. We can see the open circuit voltage at 49.42, which hits right about here. That looks like it matches. And then we have our maximum power here at 540 watts. And that's located here. This is our power curve here. You can see that matches. We need to look at the right-hand side. So you can see that this information in the table does translate over to the IV curve. And if they are older modules, degradation is to be expected, so it may diverge from the datasheet.